Yes. In the previous lecture, we were discussing exact equations, exact ordinary differential equations, exact ODEs, in fact. I told you what was the basic criteria for an equation to be exact. For example, if we have an ODE of this form, first order ODE, m of xy dx, n of xy dy equal to 0, then this ODE will be exact if partial m over partial y is equal to partial n over partial x. So this is the basic criteria for a first order ODE to be exact differential equation. Let's have another example of this exact ODE, and then we shall move forward. For example, we need to solve this initial value problem. Solve the IVP. IVP means initial value problem. Y dash is equal to xy square minus cosine of x into sine x all divided by y times 1 minus x square. Subject to an initial condition, which is y of 0 is equal to 2. So we need to solve this differential equation. If we want to solve this differential equation using the exact technique, we have to write this equation first in this form. So we have to split the differentials dx and dy. So y dash is, in fact, it is what? Dy by dx. And then multiplying, cross multiplying, you can say that it is y, पहले आप x वाली term लिख लें, so that it is x y square minus cosine of x into sine x dx, क्योंकि ये dx आप इसके साथ multiply होगा, and then ये इसके साथ होगा, फिर negative sign आ जाएगा, negative y 1 minus x square dy equal to 0. So this is, we have converted this differential equation into this form. Now we can write easily what is, or m of xy is xy square minus cosine of x into sine of x, and what is our n of xy? It is minus y 1 minus x square. So now we have m and n. We need to check this expression or this equation. So for that, we need to find partial m over partial y. What is our m? This is your m. With respect to y, x would be treated as constant. Let me add people. Now, if we want to take the derivative of this thing with respect to y, x would be treated as constant. So this whole term will become 0 because x is constant here. We have cos x, sin x, there is no y here. So this term will be eliminated here. X will be constant and the derivative of y square is 2y. So what do we get here? 2xy. Similarly, partial n over partial x, sorry. Here we have n of xy minus y. Y would be treated as constant here. So we take only the derivative of x. 1 ka derivative, 0. X square ka derivative, 2x minus 2x into minus y. So we get again 2xy. So these two things are equal. So the given differential equation is exact. Exact differential equation. Okay.
Sir?
Yes.
Sir, some of my friends said that they didn't receive the email for the class link. Maybe their attendance is low because of that.
तो उनको ईमेल क्यों नहीं मिली?
सर आई डोंट नो, जो मेरे फ्रेंड्स हैं उनको तो मैंने लिंक फॉरवर्ड कर दिया, बट आई डोंट नो कि और कितने लोगों को नहीं मिली.
Should I send them again? Maybe.
Yes sir, I think so.
Let me stop the recording. Now, when the given differential equation is exact, what happens next? I told you that when a given differential equation is exact, you can write here, therefore, given ODE is exact equation. Okay. If that equation is exact, then there exists a function f of xy such that that equation xy square, yes, xy squared minus cosine of x sine x dx minus y times 1 minus x squared dy is equal to differential of f of xy. Okay. So when an equation is exact, then there must exist a function f of xy, okay, such that the left hand side of the given equation is differential of that function. Now, if we can find that function f of xy, then I told you in the previous lecture, then by putting f of xy is equal to some constant will be the solution of the given differential equation. Okay? Now, how to find this function df of xy? अगर इसका differential लें तो it should be what? Partial f over partial x dx plus partial f over partial y dy. ठीक है? अब लेफ्ट हैंड साइड और राइट हैंड साइड को अगर हम कंपेयर करें तो आपके पास पार्शियल एफ और पार्शियल एक्स किसके इक्वल होगा? इट विल बी इक्वल टू दिस थिंग. एंड व्हाट इज दिस थिंग? दिस इज योर m of xy. It means this is your m of xy. And what is it? It is xy square minus the sine of x into sine of x. This is your partial f over partial x. आपको इस इक्वेशन को आप a कह दें. And on comparison again, what will be the value of partial f over partial y? It is the coefficient of dy. So the coefficient of dy is what? Minus y into 1 minus y square. So we can write here now partial f over partial y, and it is equal to, and what is this? This is your n of xy. And it is equal to minus y times 1 minus x square. Now you call it equation B. Now we have to now find this function f, or by using this equation or this equation. ठीक है, आपको कोई भी equation ले लें, equation A ले लें या equation B ले लें. Let's start today. In the previous lecture, I have chosen this equation, A equation, and I tried to find the function f of xy. Now, today we are starting with this equation. Now, let's start with this equation. Let me change camera. Let's go to the board 2. This one. Now, I'm going to start with the equation B. Partial f over partial y is what? It is minus y plus y x square. Okay. Now, we have to integrate this thing with respect to y because we need to find f of xy. So यहाँ पे हमारे पास डेरिवेटिव है with respect to y, इंटीग्रल लेंगे with respect to y, तो ये डेरिवेटिव और इंटीग्रल कैंसिल हो जाएंगे. So integrating with respect to y on both sides. ठीक है, तो ये पार्शियल एफ ओवर पार्शियल y आ जाएगा, सॉरी इंटीग्रल dy is equal to integral minus y plus yx square with respect to y. ठीक है, अब इसमें जब इंटीग्रल लेंगे with respect to y, क्योंकि पार्शियल डेरिवेटिव्स हैं, तो x will be treated as a constant. तो यहाँ पे डेरिवेटिव इंटीग्रल कैंसिल हो जाएंगे. What do we get here? f of x y only, and here we have to take the derivative with respect to y. तो y का इंटीग्रल क्या आ जाएगा? y square by 2 plus y का इंटीग्रल again y square by 2 into x square. x square will be treated as constant. यहाँ पे जो फंक्शन कांस्टेंट ऑफ इंटीग्रेशन हम ऐड करेंगे. इन द प्रीवियस लेक्चर आई टोल्ड यू कि जब पार्शियल डेरिवेटिव्स होते हैं, इसमें आपके पास इंटीग्रल रिस्पेक्ट टू y कर रहे हैं, तो यहाँ पे जो इंटीग्रेशन कांस्टेंट होगा दैट मस्ट बी सम फंक्शन ऑफ x. क्यों? क्योंकि पार्शियल डेरिवेटिव्स में x का डेरिवेटिव जो है अगर इंडिपेंडेंट टर्म है x की तो वो जीरो हो जाएगा. जैसे आपने यहाँ पे देखा, अगर आप इसका डेरिवेटिव, हाँ यहाँ पे जब आपने m का डेरिवेटिव रिस्पेक्ट टू y लिया, तो इसमें x वाली पूरी टर्म क्या हो जाएगी, जिसमें सिर्फ x है, ये सारी की सारी जीरो हो जाएगी. ठीक है, लेट मी चेंज द कैमरा. यहाँ पे देखें, जब हमने डेरिवेटिव लिया था इस टर्म का m का रिस्पेक्ट टू y, तो x वाली पूरी टर्म जो है ये जीरो हो गई थी. अब जब इंटीग्रल लेंगे तो आप यहाँ पे इंटीग्रेशन कांस्टेंट जो है वो एज अ इंटीग्रेशन कांस्टेंट एज अ फंक्शन ऑफ x लेंगे. ठीक है, so now we have this function f of xy which was required. We have to find this, but one thing is unknown here, which is h of x. Now we need to find this h of x. How can we find this h of x? We will use the equation. We started with the equation b. This was our equation b. Now in order to find this function, we will use equation a. In order to find h of x, we will use equation a. Now what is that equation? It is partial f over partial x is equal to m. ठीक है, अब आपके पास ये, आप इसको इक्वेशन में भी 1 कह दें. ठीक है, अब इसको यूज करने के लिए वी हैव टू टेक द डेरिवेटिव ऑफ f विद रिस्पेक्ट टू x. f का डेरिवेटिव रिस्पेक्ट टू x ले लें आप यहाँ पे, तो पार्शियल f ओवर पार्शियल x यहां से, तो ये किसके इक्वल होगा? पहली टर्म का डेरिवेटिव जीरो हो जाएगा क्योंकि इसमें x नहीं है, इसमें x है, x स्क्वायर का डेरिवेटिव 2x, तो ये आपके पास x y स्क्वायर हो जाएगा क्योंकि 2 और 2 कैंसिल हो जाएंगे, प्लस h डैश ऑफ x. अब h डैश ऑफ x क्यों आएगा? क्योंकि इसमें सिंगल वेरिएबल है x, इसका डेरिवेटिव h डैश हो जाएगा. ठीक है, नाउ दिस थिंग मस्ट बी इक्वल टू m by using this thing, equation a. What is the value of m? M is xy square minus cosine of x into sine of x. ठीक है, यहां से we get xy square plus h dash of x is equal to x y square minus cosine of x into sine of x. ठीक है, यहां से ये और ये कैंसिल हो जाएगा, and we get h dash of x is equal to cosine of x minus into sine of x. ठीक है, now हमने h dash है हमारे पास, हमने h of x फाइंड करना है, what do we do here? We have to take integration with respect to x. Now, integrating with respect to x. अब इसमें देखिए ये सिर्फ सिंगल वेरिएबल फंक्शन है, इसमें सिर्फ और सिर्फ x है, there is no y here. तो कोसाइन का डेरिवेटिव माइनस साइन होता है, ठीक है, कोसाइन का आगे डेरिवेटिव है तो आपके पास इंटीग्रल क्या आ जाएगा, it will be cosine square of x divided by 2 plus some constant of integration. अब सिर्फ हम यहाँ पे सिंगल कांस्टेंट लिखेंगे, क्यों? क्योंकि आपके पास ये सिंगल वेरिएबल फंक्शन है, इसमें y नहीं है, इसलिए ये कांस्टेंट जो है वो फंक्शन ऑफ y नहीं आएगा, इसमें पार्शियल डेरिवेटिव्स नहीं है, ये आपके पास यू कैन से सिंपल ऑर्डिनरी डेरिवेटिव है. तो इसका इंटीग्रल h ऑफ x, cos का डेरिवेटिव माइनस साइन है, cos का इंटीग्रल क्या हो जाएगा फिर, cos स्क्वायर बाय 2 प्लस अ सिंपल कांस्टेंट ऑफ इंटीग्रेशन. Now you have the value of h of x. Now हमारे पास f of x y की वैल्यू ये थी, इसमें h of x मिसिंग था. We have calculated now h of x here. We by inserting the value of h of x here, or f of x y is completed. ठीक है. Now what is the final value of f of x, or therefore inserting the value of h of x into f of x y, we have minus maybe y square by 2 को कॉमन ले लें तो 1 minus x square plus cosine square of x divided by 2 plus a constant c. ठीक है. अब मैंने आपको शुरू में बताया था कि once you have this function you put it equal to some constant. हमने यहाँ पे ऑलरेडी कांस्टेंट है, ठीक है, अगर ऑलरेडी कांस्टेंट है तो इस सारे एक्सप्रेशन को आप इक्वल टू 0 पुट कर दें. thus f of x y, या आप ये ना लिखें डायरेक्टली, वो लिखिए माइनस वाई स्क्वायर डिवाइड बाय 2 1 माइनस एक्स स्क्वायर प्लस कोसाइन स्क्वायर x बाय 2 प्लस c इक्वल टू 0. अब 0 के लिखा कांस्टेंट अगर हम लिखते हैं यहाँ पे, फॉर एग्जांपल यहाँ पे हम कांस्टेंट कोई c नॉट लिखते हैं, तो ये कांस्टेंट दोबारा उधर जाके c नॉट माइनस c, इट विल बी अनदर कांस्टेंट. ठीक है, तो फाइनली आपका सॉल्यूशन जो है उसमें कोई चेंज नहीं आएगा. तो अगेन you get cos square x by 2 equal to some constant, maybe c1. So this will be your solution of the given differential equation. Now we have to use this initial condition as well. Initial condition was y of 0 is equal to 2. Now by putting x equal to 0 and y is equal to 2 here, x equal to 0 and y is equal to 2 here. तो अगर x 0 पुट करेंगे तो यहाँ पे आपके पास 0 आ जाएगा, और यहाँ पे 2 का स्क्वायर डिवाइड बाय 2 2, so it is minus 2 plus cosine of 0 is 1 by 2 equal to c1. So 2 2s are 4, c1 is minus 3 by 2. So by inserting this value here back into the solution, you have the particular solution of the given differential equation. If you have any question, you can ask me. So this was how to solve exact equations. I'm going to pause the recording. You can ask me any question. Now let's come back to this board. I hope you get everything. If you don't understand anything, you can ask me any question. Now we are going to discuss non-exact ODEs. Non-exact means the first order ODEs which are not exact, which do not satisfy the criteria for what was the criteria partial m over partial y is equal to partial n over partial x. Now if we have any differential equation of this kind, m of xy plus dx n of xy dy equal to 0. You call this equation 1. Okay. Now, if partial m over partial x, sorry, y is not equal to partial n over partial x, then equation 1 is not exact. Okay. In some cases, in some cases, you can say, when the given ODE is not exact, we can make it exact. But it happens, it is true only for some particular kind of differential equations. Okay? Not for all. अगर given differential equation exact नहीं है, means ये criteria को satisfy नहीं करती, then we have to find, then we may find an integrating factor जैसे कि हमने लीनियर में फाइंड किया था इंटीग्रेटिंग फैक्टर ठीक है then we may find an integrating factor which after multiplying the equation 1 on both sides which after multiplying the equation 1 on both sides by that integrating factor may become an exact ODE. ठीक है in short अगर ये exact नहीं है so there might exist an integrating factor ठीक है we have to find that integrating factor if we multiply this equation on both sides with that integrating factor this equation may become exact differential equation and then we can solve it once it has become the exact differential equation then we can solve this equation by using the similar technique we use to solve the exact equations. Now, how to find that integrating factor? It's a bit technical here in the exact equations. अगर हमारे पास देखिए क्राइटेरिया क्या है partial m over partial y should not be equal to partial n over partial x. अगर हम थोड़ी सी कॉम्पैक्ट नोटेशन यूज करें तो partial m over partial y को हम लिखते हैं my और partial n over partial x को हम लिखते हैं nx. ठीक है I told you while discussing the basic notations of differential equations that partial m over partial y can be written as m subscript y. It means partial m over partial y. And nx is partial n over partial x, in fact. Now, case 1. How to find that integrating factor? If my minus nx divided by n. My is what? Partial m over partial y. We have already calculated it. Okay? We have the value of my, we have the value of nx, we have the value of n. If this fraction, or you can say the quotient, is only the function of x, if it is function of x, that is only function of x, then integrating factor in this case will be e raised power this whole thing. या आप इसको f of x लिख दें ठीक है my minus nx divided by n and you have to take integral here dx. If this is the case, the second case is case 2. If the quotient nx, अब आप इसको nx पहले my बाद में ले लें, nx my divided by m, ठीक है आप ये देखें कि आपने क्या चीज याद रखनी है कि यहाँ पे जो है ये दोनों सेम होने चाहिए, ये दोनों सेम होने, ठीक है। सो एम वाई माइनस एन एक्स डिवाइड बाई एन और एन एक्स माइनस एम वाई डिवाइड बाई एम, ठीक है। इफ दिस थिंग is a function of y only, that is a function of y only, then integrating factor is what? Can you see this? Yes, e raised power this whole thing, या आप ये g of f y लिख दें, nx minus m y divided by m dy. This will be your integrating factor, ठीक है। इंटीग्रेटिंग फैक्टर को यूजुअली यहाँ पे म्यू ऑफ एक्स वाई से डिनोट करते हैं इंटीग्रल सॉरी एग्जैक्ट डिफरेंशियल इक्वेशन में, बिकॉज दिस विल बी अ फंक्शन ऑफ एक्स वाई बोथ, एंड दिस इज अगेन म्यू ऑफ एक्स वाई, दिस विल बी योर इंटीग्रेटिंग फैक्टर, ठीक है। नाउ फॉर एग्जाम्पल द केस वन इज ट्रू and we have the integrating factor. What we do now, we multiply the given equation with this integrating factor thing. We multiply the given equation with the integrating factor. Once we have multiplied, the given equation will become an exact differential equation. ठीक है। Now, multiplying equation 1 by integrating factor mu of x y on both sides, what do we get? We get m mu of x y times m of x y dy dx plus mu of x y n of x y into dy is equal to 0. Now this is your equation 2, and this equation must be exact. Equation 2 is now exact equation. Exact ODE, you can see that. अगर एग्जैक्ट ODE है तो आपके पास ये जो dx का कोफिशिएंट है ये आपके पास एक नया m बन जाएगा. We can say that this is your m bar of xy dx plus n bar of xy dy equal to 0. Now this is your equation 3. It's same as equation 2. हमने सिर्फ इसको एक नया n bar कह दिया और इसको m bar कह दिया. ठीक है. Now this equation must be exact. ठीक है, एग्जैक्ट होने का क्राइटेरिया आप दोबारा चेक कर लें. पार्शियल m bar और पार्शियल y must be equal to partial n bar और partial x. So this must be true. ठीक है, अगर ये ट्रू है तो ये इक्वेशन अब आपके पास क्या है? एग्जैक्ट डिफरेंशियल इक्वेशन. ठीक है, अब इसका जो सॉल्यूशन होगा वो गिवन डिफरेंशियल इक्वेशन का सॉल्यूशन होगा. क्योंकि आपने इस पूरी इक्वेशन को एक फंक्शन से मल्टीप्लाई कर दिया. सो किसी भी इक्वेशन को अगर आप किसी चीज से मल्टीप्लाई कर दें दोनों साइड से, ठीक है, तो उससे कोई इफेक्ट नहीं पड़ेगा. देयर आर क्वेश्चंस इन द चैट विंडो. व्हाट आर द क्वेश्चन? Is it necessary for equation to be exact now, or there is a case where we do this and it still isn't exact? It is not always possible to find the integrating factor, but if the integrating factor exists, then by multiplying the given equation with the integrating factor, the new equation must be exact differential equation. Okay? There are non-exact equations for which integrating factor does not exist. If the integrating factor does not exist, then we cannot make the given differential equation into we cannot convert the given differential equation into exact differential equation, okay, which is non-exact at start. So the problem is that integrating factor exists. Once the integrating factor exists, the given differential equation will become definitely an exact differential equation. I hope you get it. Now let's discuss these things with the help of an example. Let's come back to now board number second. This one. Example. Example, we need to solve this differential equation, solve the following ODE. What is the ODE? Xy dx plus 2x square plus 3y square minus 20 dy equal to 0. Now this is equation 1. What is m of xy here? M of xy is xy, and what is n of xy? N of xy is 2x square plus 3y square minus 20. Okay. Now we need to find partial m over partial y, which is यहाँ पे y का डेरिवेटिव 1 हो जाएगा क्योंकि x कांस्टेंट है, तो यहाँ पे x आ जाएगा. ठीक है. पार्शियल n ओवर पार्शियल x, 2x स्क्वायर का डेरिवेटिव 4x, 3y का स्क्वायर, y कांस्टेंट है 0, 20 कांस्टेंट है 0. So we get this thing. Now you can see that partial m over partial y is not equal to partial n over partial x. So the given differential equation is not exact. Equation 1 is non-exact. या आप कह सकते हैं not exact. I hope you get it. Now let's try to find the integrating factor. Now the integrating factor is, case 1. Case 1 में आपके पास क्या आ जाएगा? आपने you have to try my minus nx over n. अब आपके पास my क्या है? My is your x. This is your my. It is x minus n. Nx is 4x. 4x divided by n. What is your n? This is your n. 2x square plus 3y square minus 20. And we can write it as minus 3x whole divided by 2x square plus 3y square minus 20. Now, what is this function? Is this a function of x only? No, we cannot eliminate y here. We cannot eliminate y here. So this is not a function of x only. Okay? This is not a function of not function of x only. So case 1 fails. You can say case 1 fails. We cannot find integrating factor by using this case 1. Now let's move to the case 2. Case 2 कहाँ पे करें हम? इसको erase कर लेते हैं दोबारा. There are questions in the chat window. Let me see. What is the question? Okay, no, there is no question. So now case 2. What is our case 2? Case 2 में क्या होगा? आपने you have to compute nx minus my divided by m now. Now what is this thing? Nx is 4x minus my is x divided by m. What is m? xy. This is the value of m. Now you can see that this is your 3x divided by xy. X and x cancel. You can say here x is not equal to 0. And the resulting expression is 3 over y. Now this is only the function of y. There is no x here. Okay? This is only function of y. अगर ये सिर्फ function of y है तो integrating factor we can find integrating factor in this case. ठीक है? So in this case integrating factor mu of xy will be what? It is integral of this whole thing, and this whole thing is equal to what? 3 over y. So it is integral of 3 over y dy. ठीक है? तो ये क्या आ जाएगा? e raised power 3 कांस्टेंट है, बाहर आ जाएगा 1 over y का इंटीग्रल नेचुरल लॉग ऑफ y. ठीक है? अब यहां से 3 इसकी पावर में जाएगा, e log कैंसिल हो जाएंगे, y क्यूब. दिस इज योर इंटीग्रेटिंग फैक्टर. ठीक है? Now, multiplying the given equation with this integrating factor, what we obtain, multiplying equation 1 by mu of xy means y cube on both sides. ठीक है? दोनों साइड्स पे मल्टीप्लाई कर दें आप इस इंटीग्रेटिंग फैक्टर से, तो हमारे पास जो गिवन इक्वेशन थी वो क्या थी? लेट मी राइट इट अगेन. देयर है, अब बस ये इक्वेशन थी. ठीक है? इसको आप y क्यूब से मल्टीप्लाई कर दें. एक्स वाई क्यूब है, यहाँ पे y है तो ये y4 हो जाएगा. dx प्लस y क्यूब से मल्टीप्लाई करेंगे 2x स्क्वायर y क्यूब प्लस 3y5 माइनस 20y क्यूब. ठीक है? ये आ जाएगा साथ में dy इक्वल टू 0. नाउ दिस इज योर न्यू इक्वेशन which we can call equation 2. ठीक है? इक्वेशन 1 और इक्वेशन 2 का सोल्यूशन क्या होगा? सेम होगा. क्यों? क्योंकि यहां से y क्यूब को कॉमन ले लें आप दूसरी साइड पे, या वो जाके 0 हो जाएगा, तो इक्वेशन we get the same equation. Okay? Now our new m prime of xy या m bar of xy is xy4, and n bar of xy is what? It is 2x square y cube plus 3y5 minus 20y cube. ये आपके नए m और n आ गए. अब आप यहां पे देखें पार्शियल, दोबारा अगर हम क्राइटेरिया चेक करें, यू डोंट नीड टू चेक इट, बट आप फिर भी देख लें क्योंकि ये एग्जैक्ट बन जाएगी. दिस मस्ट बी एग्जैक्ट इक्वेशन. नाउ पार्शियल m bar और पार्शियल y इज व्हाट नाउ? 4y क्यूब और x, 4xy क्यूब, और partial n bar over partial x now is what? Respect to x derivative लेंगे तो 2x square, x square का derivative 2x, 2 into 2 4x y cube, so 4x y cube. बाकी ये function of y है, respect to derivative 0 हो जाएगा, यहाँ पे भी x नहीं है, ये भी 0 हो जाएगा. Now you can see that we have 4xy cube, 4xy cube. So these two things are equal. Now the given equation has become now equation 2, and equation 2 is exact differential equation. Once the equation has been converted into exact differential equation, we can solve this equation by using the similar method we used for solving the exact differential equation. I hope you get it. I hope you can solve this differential equation now by using the similar technique, and you can get the solution. If you have any question, you can ask me. Sorry. You have to check both cases. ठीक है? कोई भी केस दोनों में से ट्रू हो सकता है. इट इज नॉट पॉसिबल कि दोनों केसेस ट्रू हो. ठीक है, कोई एक केस ट्रू होगा. तो कोई एक केस ट्रू होगा. अकॉर्डिंग टू दैट यू कैन फाइंड द इंटीग्रेटिंग फैक्टर. You multiply the given differential equation by the integrating factor and make it an exact ODE, and then you can solve that exact ODE using the similarity. So if you have any question, you can ask me. I have included a couple of more examples here in my notes. You try to solve these examples. I hope you get it. Still, if you have any problem, you can discuss with me these kind of problems in the next lecture.